we will see one more numerical of the photoelectric effect. So, the question is, a photon of wavelength 4 into 10 to the power minus 7 meter strikes on metal surface. The work function of the metal is 2.13 electron volt. Calculate energy of photon in electron volt. Kinetic energy of the emission and velocity of photoelectron. Okay, so we have wavelength, we have work function in electron volt. Okay, so the value of 1 electron volt is given as 1.6020 into 10 to the power minus 19 joules. Okay, so now let's calculate. We need the energy of photon. What is the energy of photon? H nu, that is hc by lambda. So nu equal to c by lambda. So 3 into 10 to the power 8 meter per second by, what is the wavelength? 4 into 10 to the power minus 7 meter. It comes as 7.5 into 10 to the power 14 second inverse or hertz. So E will be 6.626 into 10 to the power minus 34 joule second into 7.5 into 10 to the power 14 second inverse. So this comes as 4.97 into 10 to the power minus 19 joule. Now 1.6020 into 10 to the power minus 19 joule equals to 1 electron volt. So what will be 4.97 into 10 to the power minus 19 joule? This will be this. So this comes as 3.1024 electron volt, or we can consider it as 3.10 electron volt. So we have the value of energy in electron volt. Now we need kinetic energy of the emission. Kinetic energy, we know kinetic, if total energy E is equal to work function plus kinetic energy. Then kinetic energy is equal to total energy minus work function. So we have kinetic energy equal to 3.10 electron volt minus 2.13 electron volt. So this is, we get kinetic energy equal to 0.97 electron volt. So if 1 electron volt is equal to 1.602 into 10 to the power minus 19 joules, then this can be written as 0.97 into 1.6020 into 10 to the power minus 19 joules. So this becomes 1.55 into 10 to the power minus 19 joule. Now we need the velocity of photoelectron. What is kinetic energy? Kinetic energy is equal to half of mv square, where m is the mass of electron. We know the mass of electron is 9.1 into 10 to the power minus 31 kg. We need velocity of electron, that is v. So if k is equal to half mv square, then v squared is equal to 2k by m. So v will be equal to square root of 2k by m. Okay, so let's see v square. V square is equal to 2 into 1.55 into 10 to the power minus 19 joule by 9.1 into 10 to the power minus 31 kg. Now we need some unit conversion. What is energy? Energy is force into displacement. And what is force? Force is mass into acceleration. So joule equal to, unit of force is Newton. So Newton meter, right? So, and what is Newton? Newton is kg meter per second square, or kg meter second to the power minus 2. So joule will be kg meter into meter, that is meter square, and second to the power minus 2. So v square is equal to, since we will have to calculate the square root, so let's take these figures in round numbers. 2 into 1.5 can be rounded up to 2 into 10 to the power minus 19 kg meter square second to the power minus 2 by 9.1 can be considered as 9 into 10 to the power minus 31 kg. So kg and kg is cancelled. So we have v square equal to 4 by 9 into 10 to the power minus 19 plus 31. So this comes as 12. 10 to the power 12 meter square second to the power minus 2. So v will be square root of 4 by 9 into 10 to the power 12 meter square second to the power minus 2. So we get v as 2 by 3 into 10 to the power 6 meter per second. So this comes as 0.66 into 10 to the power 6 meter per second, or it can be written as 6.6 into 10 to the power 5 meter per second. So we have calculated energy in electron volt, we have calculated the kinetic energy, and we have calculated the velocity. Next we will talk about the atomic spectra. Atomic spectra so actually before starting atomic spectra, we need to know that electromagnetic spectrum can be of two types: continuous and quantized. Quantized means with discrete energy levels. Now, what is continuous spectrum? One very good example of continuous spectra is visible light. We know that white light consists of many colors. It consists of a series of colored bands. So when white light passes through a prism, it splits up into various colors from violet to red. And when it passes through the prism, it shows deviation. Now, since red light has the longest wavelength and violet light has the shortest wavelength, so red light deviates the least and violet lights deviates the most, and the other wavelengths that are present in between, that is blue, green, yellow, orange, all these colors deviate in certain angles. So since all these colors have different wavelengths, so they deviate at different angles. That is why when white light passes through a prism, what happens? We know that light needs a medium to travel. The light can also travel through vacuum, but its speed changes when the medium changes. So when it is entering glass from air, then the speed will change. Therefore, deviation will occur. Due to the different wavelengths of these different colors, deviation is occurred at different angles. That is why white light splits up into its constituent colors while passing through a prism. So, if this is the prism and white light passes through it, it deviates once inside the prism. If this is this original path, it deviates, and when it comes out of the prism, it comes out in different colors. This can be observed in white light splits up to give VIBGYOR, and this can also be observed in rainbow. Now, the interesting fact is this: these colors like red, yellow, blue, green, these colors are not discrete colors. Not discrete. We know in real life that we don't have just one shade of red or one shade of yellow. We have various shades of yellow. Like This is also yellow and this is also yellow, right? This is green and this is also green. So these are different. Why these are different? Because these colors merge into one another. Like violet merges into blue, blue merges into green, green merges into yellow, and so on. So infinite shades are formed. Infinite shades are formed in between. That's why we have so many shades of red, so many shades of green, and so on. Since these occur in infinite shades, we call them as a continuous spectrum. But this is not the case with every kind of spectrum. We see that atomic spectra can be of two types: absorption spectra and emission spectra. Now, what is absorption spectra? When light is incident on some matter, for example atoms or electrons, particles absorb energy from the radiation and gets excited to higher energy levels. When the particles absorb energy, the spectra that is obtained from this phenomenon is known as absorption spectra. But the higher energy level or higher energy state is unstable. So, to come back to ground state is the lowest energy state and it is stable. So, particles emit energy in the form of radiation. This emitted energy, the spectra obtained from this emitted energy is called the emission spectra. And these spectra, absorption and emission spectra, are quantized. We will read details of absorption and emission spectra. It is observed that in the absorption spectra, when it is recorded, dark lines are seen in between, and when the emission spectra is taken, there are bright lines that is observed, and these bright lines correspond to the dark lines in the absorption spectra. So from this it is very clear that when the particles absorb energy, for example the electrons, when they absorb energy, they do not absorb in a continuous spectrum. They absorb very specific wavelengths and they also emit very specific wavelengths. So the spectra is obtained in the form of multiple lines. So they are called line spectra. We will discuss about the line spectra in the next lecture. Thank you.